Welcome to this exploration of NEAR protocol, a cutting-edge sharded Layer 1 blockchain. NEAR represents a new approach to solving one of blockchain's most persistent challenges: scalability. Unlike traditional blockchains that process transactions one after another on a single chain, NEAR uses an innovative technique called sharding to dramatically increase transaction processing speed while keeping costs low. Throughout this presentation, we'll uncover how NEAR's unique architecture enables it to scale efficiently and what makes it stand out in the crowded blockchain landscape. To understand NEAR's innovation, we first need to understand the problem it solves. Traditional blockchains operate as a single chain where every transaction must be processed sequentially, one after another. This creates a bottleneck, much like having only one checkout line at a busy grocery store. As more users join the network and submit transactions, the system slows down, fees increase, and the user experience deteriorates. NEAR's solution to this fundamental challenge is parallel processing through sharding architecture. Instead of forcing all transactions through a single pipeline, NEAR splits the workload across multiple parallel chains, dramatically increasing the network's capacity to handle transactions simultaneously. Sharding is a technique borrowed from database management that divides a blockchain into multiple parallel chains called shards. Think of it like dividing a large library into sections, with each section having its own librarian. Rather than one person managing everything, multiple librarians can serve visitors simultaneously, making the entire system much more efficient. In blockchain terms, each shard processes its own set of transactions independently and in parallel with other shards. When you combine all the shards together, they form the complete network, but the workload is distributed rather than concentrated. This parallel processing approach allows the blockchain to scale its capacity as more shards are added, providing a path to handle millions of transactions without overwhelming any single node or validator. NEAR's implementation of sharding is called Nightshade, and it has some unique characteristics that set it apart. Unlike other sharding approaches where different validator groups manage separate shards in isolation, Nightshade maintains a single unified blockchain with multiple shards. Here's how it works. All validators in the network validate all shards, ensuring maximum security and consistency. However, each validator is assigned to produce blocks for only one specific shard. This design gives NEAR the scalability benefits of sharding while maintaining the security guarantees of a unified chain. It's an elegant solution that avoids the complexities and security risks that can arise when blockchain networks become too fragmented. Let's break down the Nightshade process into 4 key steps. First, chunk production. Validators produce chunks, which are pieces of blocks for their assigned shard. Think of chunks as the individual contributions from each shard. Second, block assembly. A designated block producer collects chunks from all the shards and assembles them into a single complete block. Third, validation. All validators in the network verify all the chunks collectively, ensuring that everything is correct and consistent. Finally, finalization. The complete block, containing transactions from all shards, is added to the single blockchain. This coordinated approach ensures that even though processing is parallelized across shards, the network maintains a unified state and strong security guarantees. One of NEAR's most powerful features is dynamic resharding, which allows the network to automatically adjust the number of shards based on actual usage and demand. Imagine a shopping mall that could magically add or remove checkout lanes based on how busy it is at any given moment. When network usage is high and transaction volume spikes, NEAR can increase the number of shards to handle the load, scaling up capacity exactly when needed. Conversely, during periods of low activity, the network can reduce the number of shards to minimize overhead and reduce operational costs for validators. This flexibility makes NEAR future-proof. It can grow with adoption without requiring manual intervention or network upgrades, automatically adapting to meet the needs of its users. NEAR's sharding implementation has been rolled out in carefully planned phases. Phase 0 began with a single shard, essentially no sharding, establishing the foundation. Phase 1 introduced state sharding with chunk-only producers, where the blockchain's data was divided across shards, but processing remained unified. This phase proved the technical feasibility of the approach. Phase 2 brought full validator participation across all shards, completing the implementation of both state and processing sharding. This phase ensures that the network is fully sharded while maintaining security. Finally, Phase 3 enables dynamic resharding, allowing the network to automatically adjust shard count based on real-time demand. Each phase builds on the previous one, gradually increasing the network's scalability while maintaining stability and security throughout the transition. A critical challenge in any sharded system is enabling different shards to communicate with each other. NEAR solves this through a mechanism called receipts, which enable asynchronous message passing between shards. Here's how it works. When a transaction on one shard needs to interact with an account or contract on another shard, the transaction creates a receipt. This receipt is then sent to the target shard, carrying the necessary information and instructions. The target shard processes the receipt and executes the requested action. This asynchronous approach means that cross-shard transactions don't need to wait for immediate responses, allowing the system to maintain high throughput even when shards need to coordinate. The receipt system is what enables NEAR to function as a unified network despite being split into multiple shards. NEAR's sharding architecture delivers impressive performance metrics that make it competitive with traditional centralized systems. The network achieves block times of approximately 1 second, meaning new blocks are produced and added to the chain every second. Finality, the point at which transactions become irreversible, occurs in approximately 2 seconds. This near-instant finality is crucial for applications that need quick confirmation, such as payments or trading. In terms of throughput, NEAR has the potential to process over 100,000 transactions per second as more shards are added to the network. And all of this comes with low transaction fees, making NEAR accessible for everyday users and practical for high-volume applications. These performance characteristics position NEAR as a blockchain capable of supporting mainstream adoption and real-world use cases at scale. Let's recap the key points about NEAR protocol's approach to scalability. First, Nightshade Sharding enables parallel transaction processing by dividing the network into multiple shards that work simultaneously, dramatically increasing throughput. Second, dynamic resharding allows the network to automatically adjust to demand, scaling up during peak usage and scaling down during quiet periods, making NEAR adaptable and efficient. Third, despite being sharded, NEAR maintains a single blockchain with a unified security model, ensuring that the network is as secure as a non-sharded chain while gaining all the benefits of parallelization. Finally, with fast finality times and high throughput scalability, NEAR is positioned to handle the demands of mainstream adoption. These features make NEAR protocol a compelling solution for developers building decentralized applications that need to scale to millions of users.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.